Hey IBers, today I'm going to discuss the periodicity topic of IB chemistry. I only go through the SL portion because I'm an SL student. Please try to ignore the message at the bottom that says this is a free trial. It's annoying, but I'm going to try to work around it. The first thing you need to identify yourself with is the periodic table, hence the name periodicity. Group 1 is made up of the alkali metals, Group 7 is made up of the halogens, and Group 8 is made up of noble gases. The next thing you need to know about is atomic radius. Atomic radius is defined as half the distance between the nuclei of two bonded atoms of the same element. In other words, it's the distance between the nucleus and the valence electron. A lot of the time in the IB questions, in the IB exam questions, they'll ask you to define these kind of terms, and so it's important that you know the definition by heart. So what you need to know is that as you go down any group, the atomic radius is going to increase because there will be more occupied valence shells, higher energy levels in other words. However, going across the period, the number of protons in the nucleus would increase, which would increase the electrostatic attraction in the atom and attract the electrons closer to the nucleus and reduce the atomic radius. So, as you go across a group from lithium to fluorine, the atomic radius is going to decrease. Okay, moving on, you need to know about the ionic radius and how it changes. Cations are positive ions and anions are negative ions. Both the atomic radii of cations and anions increase as you go down a group, as there would be more occupied valence electrons. More occupied valence shells. Cations such as sodium, sodium plus, have a smaller radius than sodium, which is a neutral atom, because they would have fewer electrons yet the same number of protons. This increases the electrostatic attraction and pulls the outer electrons in and decreases the atomic radius. On the other hand, anions, such as chlorine negative, have a larger radius than chlorine because they have more electrons than protons. This increases the electron repulsion, and because the thing is, when you add electrons, the internal repulsion between the electrons within the atom causes the radius to increase in size. Alright. The definition of periodicity is the repeating pattern of physical and chemical properties shown by different periods. This includes melting points, electronegativity, first ionization energy, etc. I've seen them ask this question, how to define periodicity, in one of the IB exam paper questions, the past paper questions. So it's important that you learn this definition. Okay, so to start off, we're going to talk about melting point. Melting point depends on two things: the structure of the element and the type of intermolecular forces holding the atom together. Across period 3, Na, Mg, and Al are metallically bonded. The metallic bond increases in strength as the number of valence electrons increase. So, magnesium has a higher melting point than sodium, and aluminum has a higher melting point than sodium and magnesium. Silicon is a little different. It has a macromolecular covalent structure with very strong intermolecular bonds, which causes it to have the highest melting point in period 3. Then moving on to phosphorus, sulfur, and chlorine, they all have simple molecular structures with weak van der Waals forces, and so have relatively low melting points. If you don't know what van der Waals forces mean, just stay tuned for my upcoming videos talking about bonding. It'll explain what these type of bonds are. Okay. Finally, the noble gases exist as single atoms with very weak intermolecular forces and have very low melting points. Okay. There is also a trend in melting points within groups. As you go down group 1, the melting point decreases because as the atoms become larger, the strength of the metallic bond decreases. But however, down group 7, the melting point increases because as the atoms become larger, the van der Waals forces increase. Okay. The next thing I want to talk about is the trend of electronegativity. Electronegativity is the attraction an atom has for a shared pair of electrons with It's the attraction an atom has for a shared pair of electrons when it's covalently bonded to another atom. This word, covalently bonded, is so important. And don't forget to include that in your definition if they ask you on the exam. Alright, so as the size of an atom decreases, the electronegativity increases because the distance between a small atom and its shared pair of electrons is so short, and so it's able to attract the electron more. The atomic radius, as we've already discussed, decreases down the period, and increases down a group. The easiest way to remember this is that fluorine is the most electronegative atom in the periodic table. Another definition that you need to learn is first ionization energy. I've already discussed this in my atomic structure topic video. However, I'm going to quickly discuss it again. First ionization energy is defined as the energy required to remove one electron from an atom in its gaseous state, and it can be written as this formula here. Don't forget the gas symbols because that's really important and you won't get any marks if you don't put it in. First ionization energy decreases down a group as the valence electron is further from the nucleus, and so less energy is required to remove it. First ionization energy increases across a period because across a period there are a greater number of protons in the nucleus, which increases the electrostatic attraction that pulls the valence electrons closer in and makes it more difficult to remove. Alright, for the next part of the video, I'm going to be discussing chemical properties of elements in the same group. For the group 1 alkali metals, which include lithium, sodium, potassium, Rb, and Cs, they are all very reactive metals. They're good reducing agents because they can easily lose an electron. Their reactivity increases down a group because with increasing atomic radius, the less energy is required to remove the valence electron. They all react with water to form an alkali solution, of metal hydroxide and hydrogen gas. An example of this is written here with sodium and water. A reaction between sodium and water produces lithium and water produces lithium hydroxide and H2. They also react readily with halogens to form ionic salts. An example is given here of sodium reacting with chlorine. I forgot the 2 for chlorine. Giving you sodium chloride. The group 7 halogens are good oxidizing agents because they react by I didn't mention what they are. The halogens include fluorine, chlorine, bromine, and iodine. They're good oxidizing agents because they react readily by gaining an electron. Their reactivity decreases down the group because with increasing atomic radii, it's more difficult to attract electrons. Chlorine is a stronger oxidizing agent than bromine. And both chlorine and bromine are stronger oxidizing agents than iodine, so they can displace an electron from iodine. Here are some formulas that demonstrate how chlorine can displace an electron from bromine and from iodine, and how bromine can displace an electron from iodine. We can detect the presence of halide ions in a solution by adding silver nitrate. The silver ions react with halide ions to form a colored precipitate of the silver halide. Silver chloride, so I demonstrated this by the formula here, chemical formula. So silver chloride is white, silver bromide is a creamy color, silver iodide is a yellowy color. Okay. And finally, the last thing that we're going to discuss in this topic, is the change from metallic to non-metallic nature of the elements across period 3. The metals, sodium, magnesium, and aluminum are all good conductors of heat and electricity. Silicon is a metalloid, which means that it has properties of a metal and a non-metal, and it is a semiconductor. The nonmetals, phosphorus, sulfur, and chlorine and argon, do not conduct electricity. Another way to distinguish metals from nonmetals is that metal oxides tend to be acidic, metal oxides tend to be basic, while non-metal oxides tend to be acidic. So, for example, I gave the formulas of oh yeah, so you have Na2O, so sodium oxide, and magnesium oxide, and these are basic, okay? And although aluminum is a metal, its oxide is amphoteric, which means that it can either be basic or acidic. Alright, and nonmetal oxides, they tend to be acidic, as seen by SO3 and P4O10. Alright, so metals can also be distinguished from nonmetals by their chemical properties. Metal oxides tend to be basic, whereas nonmetal oxides tend to be acidic. So, for example, sodium oxide and magnesium oxide are both basic and react with water to form hydroxides, as shown by the two chemical formulas here. Aluminum is a metal, but its oxide is amphoteric, which means it can either be a basic or acidic depending on whether it's reacting with an acid or base. The remaining elements in period 3 have acidic oxides, for example, sulfur trioxide, and it reacts with water to form sulfuric acid, and phosphorus pentoxide reacts with water to form phosphoric acid. The chemical formulas are all written here. These are, sometimes it gets really messed up and I don't know why. Sometimes things get erased on my video. Anyway, these are really important formulas that you need to learn. You honestly just need to memorize them off by heart, because they'll ask you how to demonstrate through chemical formulas and reactions with water how the trend changes from basic to acidic in the oxides across period 3. It's also going to ask you in the IB questions, past paper questions, or in general in exam questions, they're going to ask you to show how aluminum is amphoteric. So you'd have to give the two formulas here to show it reacting with HCl and reacting with NaOH, producing these two products. So I hope this has helped you. This is not a very in-depth video. However, it kind of gives you an overall idea of what you know, just the basic things that you need to know, and everything is really concise. So I hope this has helped you. If you have any questions or any requests, please just either send me a personal message or just write a comment. Thank you, and I hope this has helped.